we have definite integral between the limit 0 to pi by 2 log sin x minus log sin 2x being integrated with respect to x. In all the 10 integrals that we are going to discuss, like we have discussed 2 of them, here we are with the third one, we have to make use of minimum of one of the properties of definite integrals. So here we go. I can again start with the basic assumption. I take this integral as I, mean whatever value we take it as I, and we have to solve it for I. Now, here, if we look at the formula for log of m raised to the power n is n log m. Now, in this case, we are going to use the reverse of it. That means n log m is already with us. This is like 2 log sin x. This is n log m is already with us. We'll prefer to write the same thing as log of m raised to the power n. So here, this integral can be written as 0 to pi by 2 log sine square of x. Be very much careful. This is square of the ratio, not the square of the angle. X is the angle here. It remains x. But this is sine square of x, which is as good as sine x whole square also. And this log sine 2x dx as it is. Now, the next formula for log is log of m minus log of n. Log m minus log n is log of m by n. So using this formula, in place of m we have sine square x, in place of n we have sine 2x. So when we apply this formula, so what we get is, you can see log is appearing once, so we have log here. Then we have sine square x, which occupies the numerator, and sine 2x, it occupies the denominator. So we reach this step. Now let us simplify it further. We have 0 to pi upon 2 log sine square x, we keep it as it is for the time being, and sine 2x can be written as 2 sine x cos x, and this dx remains as it is. Now you can observe single power of sine can be cancelled out this way. We are left with one power of sine in numerator, and we have 2 cos x in the denominator. If I adjust cos under sine, sine divided by cos makes it tan. So the integral becomes 0 to pi upon 2 log tan x whole divided by 2 dx. Now log of m upon n, once again applicable, but this time the reverse of it this way. So we'll be able to write the same thing as 0 to pi upon 2 log tan x. We'll split this into two integrals, log tan x minus log 2. So I'll write both the things in separate integrals. It's 0 to pi upon 2 once again, and log 2 appears in the second integral. Now, for the second part, this is very, very easy. This is minus as it is. Log 2 being a constant, can bring it out. Within the integral means the integrand will be 1 only. 1 has integration x. And after that, we just need to apply the limits of integration. If you recall this question, this was the second question we discussed. 0 to pi upon 2 log tan x dx. This we have already discussed, and its value comes out as 0. If you refer to the second question of this video, then you'll find 0 to pi by 2 log tan x dx. We've proved that this is equal to 0. So left hand side remains I. So final answer is I equals to, you can feed pi upon 2 here and subtract 0 from there. So you get minus of pi upon 2 log 2 as our final answer. So this is the third question in the series of 10 most important questions. This was the third question we discussed. So now over to the fourth question in the sequence.